Good morning, students. Am I audible better?
Audible, sir.
So we started with AC beta. Last part of the class, we have been done with your some of the relations of your I averages values and IRMS values. I hope you remember them. How to calculate the I average and as well as of your IRMS part of a relation. Chalo. In today's session of a class, what is the day today? 26 kada. So it is 26, 12, 20, 20. Okay. So let us try to go for the next part of relation beta. So I hope you got an idea how to calculate the average values beta, everyone. గుర్తుందా మర్చిపోయారు అందరూ? చలో. See this point beta. The average heat produced, the average heat produced during a cycle, during a cycle of alternating current, that is AC, is same as produced by DC. అంటే ఒక కంప్లీట్ సైకిల్ లా when current is being flowing, whatever amount of average heat is being produced, that will be same as the heat produced by your DC. Okay, so with what current we can write? With I is equals to your IRMS current. That is, I can write that DC is equivalent to direct current is equivalent to IRMS value of your alternating current. DC current is equivalent to what beta? IRMS of your is. This is very important for doing calculations beta. So what is the condition we are writing? The average heat produced during a complete cycle. Ante one complete cycle ante itla. In one complete cycle of your AC, entaithe current heat produce avutundo, that heat is same as of your DC with I is equals to IRMS. That is, DC is equivalent to your IRMS of your alternating current. ఎలా అనేది చూడండి ఒకసారి. Like say for example, alternating current formula ఎలా calculate చేస్తాం అన్నట్టు? Let I is equals to your I naught into your sine of your omega into t. I is equals to I naught into sine omega t. So the instantaneous value of heat produced per second will be equal to how much beta? The instantaneous value of heat produced. Instantaneous value of your heat produced per second in a resistor R. In a resistor capital R. So what is the heat formula bana? Current electricity la manam already current electricity me kaledemo adi. H is equals to I square into your R is your heat produced beta. Okay, so what is the value of your I? I value is equals to your I naught square into your sine square omega into t into your capital R. So దీని యొక్క average value ఎలా calculate చేస్తాం? I already told you all to calculate the value of an average. I average value every time will be equal to integral of your heat produced H into dt divided by your integral of your dt. Limit for one complete cycle అనుకున్నాం కాబట్టి 0 to your capital T is one complete cycle. So that is equals to h value దీంట్లో వేసుకోండి. I naught square constant, capital R is also constant, so I'm directly bringing out that one. So it is I naught square into your R, integral of your sine square omega into t into your dt part. ఈ dt ఉంది కాబట్టి here it is nothing but dt divided by integral of dt is nothing but t. So I'm writing directly the value of that one, capital T. So this value will become how much be better? Integral of sine square omega t into dt is nothing but I told you already in basic mathematics, half. So this value will come for me half into I naught square into capital R. So this value is nothing but of your I RMS square into capital R part of relation. I RMS is equal to how much for me? I naught by your root 2 kabatti H average current whatever we are writing is equals to half into I naught square into R, that is equals to I RMS square into your R part of relation. So this is the value of your average heat produced in an alternating current part of relation. So see the definition what you are doing here. The average heat produced during a cycle of your alternating current is same as produced by the DC with I value is equal to how much for me? IRMS part of relation. So I can say that DC current is equivalent to your IRMS alternating current part of relation. And that value of the heat I am getting as how much? I average or H average is equals to IRMS square into your capital R part of relation. Okay. So therefore I can say that heat produced in per second, heat produced in per second by your DC. So this will be equal to how much better? Heat average heat is equals to, this one is I DC square into capital R, isn't it? Because I'm taking here current due to your DC is equals to your how much for me? IRMS part of relation. So average heat produced will be equal to your I DC square into your R. In this one, we need to remember one very important term called as of your form factor. Form factor is nothing but beta, the ratio of your RMS value to the average value. The ratio of RMS value divided by your average value. That is nothing but equal to your IRMS. That is nothing but of your IRMS divided by your I average. That is equals to your I naught by your root 2 divided by your 2 into I naught divided by your pi. So that will be equal to your pi by 2 into your root 2. So that value is approximately 1.11 beta. 1 by 2 root 2 value into pi value is also constant. This is called as of your form factor. So the ratio of RMS value to the average value is called as of your form factor part of relation. Clear? We got the EMF, we got the IRMS part of relation. So IRMS current ochindi, VRMS kuda ochindi. So I think we also got VRMS value of a current kada. We have got ERMS of your current, I average ochindi. So I told you how to calculate these values basically. So I average we got it. Okay, so we got all the relations. V average formula చెప్తారో సార్ ఎవరన్నా AC డైనమోలో in AC generator or a dynamo part of relation V average value ఎంతనన్నా V average is equals to your 2 into V naught divided by your pi. అదే విధంగా VRMS value ఎంత VRMS is equals to under root of your mean of your square, that is nothing but of your V naught by your root 2. Already నేను ఇది కరెంట్స్ కి డిరైవ్ చేశాను. సో just thing is for the EMFs will also be the same for the given conditions. Okay, now let us try to enter into The next heading, that is simple AC circuits. Your simple AC circuits. Number one, only resistor is connected. Only resistor, or I can say AC alternating current through resistor. AC through resistor. When alternating current is been connected to resistor, how it will be functioning? Alternating current through a resistor. And how do you draw the diagram for this one? You see better. We have got a resistor right now here. This is your resistor. Now instead of connecting it to your battery, what you do is you connect it to your alternating circuit. This is your alternating circuit. That is nothing but of your AC, and this one is your resistor capital R. So from this alternating current, there is a flow of a current, that is nothing but of your I. Now potential of this one is always V is equals to V naught into sine of your omega into T. ఇది ఆల్రెడీ నేను మీకు స్టార్టింగ్ లో చెప్పాను. When alternating current is been passing through your dynamos part of relation, see, when EMF is being connected, the EMF in this one is given by the formula E is equals to E naught into sine omega T, or else this can also be written as V is equals to V naught into your sine omega T. So this is the EMF of an alternating current or AC dynamo part of relation. So the same thing what I am writing here is right now, for an alternating current through a resistor, the EMF of this alternating current is always V is equals to V naught into sine omega T, but it is always a constant. That means as we know that relation, V is equals to V naught into sine omega T, then what will be the current passing through this one beta? Current will be equal to how much for me? I is equals to your V by your R. V value already we know. So this one is V naught into your sine of your omega into T divided by your capital R. V naught by R is nothing but equal to your how much? I naught. So this one is I naught into sine of your omega T. So this is your current. So I is equals to your I naught into your sine of your omega into T part of relation. So actual potential in this is my first equation, and this is your second equation. So this much amount of EMF of alternating current when it is been connected to resistor, the current again I'm getting as I is equals to I naught into sine omega T. Now see, this is the sine function, this is also sine function. Are you getting anything right now of any difference in these two signs beta? No gada. So the terms written after the sine or cos denotes the phase beta. దీని తర్వాత ఏదైతే రాస్తామో that will represents the phase. That means whenever an alternating current is connected to a resistor, there is no change in the phase. This is sine omega T, this is also sine omega T. So I can say that in circuit containing R voltage, voltage and current are in the same phase. I can say here right now, voltage and current, voltage and current are in same phase. They are in your same phase. That is, when voltage is zero, the current is also zero. That is, when voltage is zero, current is also zero. Current is zero. When voltage is maximum, when voltage is maximum, current is also maximum. Current is also maximum. Okay, that means they are in same phase. Both of them are in sine function gabati. So if I am drawing a graph for this one, so this is your graph which you need to remember better. So this is your x-axis and this is your y-axis. We are taking the voltage or we are taking the current on your y-axis part of relation. So this is your voltage or your current, and here I am taking in terms of this one is nothing but of your time t. That means this function will be somewhat like this. Okay, and if this is your current, that is nothing but of your I naught part of relation, this will be your voltage, this is nothing but of your maximum current. Both of them are in the same phase kada. So this one is nothing but like, say for example, I naught. In the same way, voltage will also be little bit higher for this one, or else if I take first one as of voltage, if this one I am taking it as of your voltage V naught, next one is we are getting the current in this one, so current is also in the same phase like this. Okay, that means this is your current right now here. So this one is your I naught. See, both of them are sine functions. So both of them are in the same phase. So I can say that voltage and current are in your same phase. This is the thing which you need to remember for your examinations point of relation beta. Voltage and current are same. Voltage and the current are in the same phase, for the given condition. Clear? So when alternating current is passing through resistor part of relation, there is no phase difference between the voltage and as well as of your current. Both of them are getting the sign. Whatever the term we get after the sign, that is a sign plus something, that will represents me the phase beta that you already know in the SHM part of relation. So whenever you are writing an alternating current resistor, this is the what is standard condition which you always need to remember beta. You need not change this one. This is constant for every alternating sources whatever you are connecting. So whenever a current from alternating current is been passing through resistor, voltage and the EMF current will be in the same phase part of relation. Next one is, let us try to talk about sorry. Next one is, what happens when AC is connected to, second one, AC through inductor. AC through inductor. What happens when an alternating current is being connected to an inductor part of relation? See what exactly is happening, you see right now. So just connect an alternating current. So this is your inductor, this is your inductor, and this inductor is connected to what beta? Alternating current. This is being connected to your alternating current. This is your alternating current, like this. Okay, and this is your L. Now from this one there is a flow of current. Then potential enta eppudu V is equals to V naught into sine of your omega into t, or else we can even write this one as E. E is equals to E naught into sine of your omega into t. E naught is equals to how much beta? Ban into your omega, that we already know it from the given condition. So known source of your EMF condition, whatever we are connecting, V is equals to V naught into sine of your omega into t. This is my first equation. Now induced EMF across the inductor will be equal to how much beta? When current is being passing right now, I can say induced EMF across inductor, across your inductor. What is an induced EMF across the inductor? Formula gurtunda, E is equals to minus of your L into your di by your dt. E is nothing but of your V also beta. V is equals to your E is equals to minus of your L into di by your deta, or part of relation. Now they apply the Kirchhoff voltage law for this one beta. Kirchhoff rule by relation. So by Kirchhoff rule, I can say by Kirchhoff's second law. That is nothing but voltage law. That is KVL. In a closed loop, if I am writing. So whatever the EMF is across this one, and EMF across this one must be equal to how much for me? 0. Isn't clear? So this will be equal to V naught into your sine of your omega into t, minus, in this one it is minus kabati, L into your di divided by your dt must be equal to 0. This is the voltage of your alternating current plus voltage of your inductor must be equal to 0. This minus kabati minus vachesindi. If this it goes on other side, I can write this one as of your V naught into your sine of your omega into t is equals to your L into your di by your dt. Now from this one, write the value of di by dt. How much you are getting, you see? Di divided by your dt. Di by your dt is equals to, this will become for me V naught divided by your L into sine omega into t. So it is V naught by L into sine omega t into, this one is nothing but of a t part of relation. That means I can get the value of current right now. You take this dt on this side. If I need to calculate the value of current, I is equals to V naught by your L into sine omega t into your dt. Now integrating on the both the sides right now. So if I am integrating it, integrating on both sides, integrating on your both sides, what I am getting, you see, integral of your di is equals to, in this one V naught by your L is a constant, integral of your sine omega t into your dt. Okay now, so integral of di is how much beta? I. That is equals to integral of sine omega t into dt is how much beta? cos of your omega t divided by omega in terms of minus. So this will be minus of V naught by L into omega into this one is nothing but of your cos of your omega into t. I hope you got this idea. Integral of sin omega t into dt is nothing but cos omega t divided by omega. Omega ఇక్కడ వచ్చేసింది కాబట్టి I is equals to minus of V naught by L omega into cos of your omega t. In order to remove this minus sign, I can write this one as I is equals to V naught by your L into your omega minus of cos omega t can be written as of your sin of your omega t minus of your pi by 2. అవునా కదా? So this is your current whatever you am getting. I is equals to your V naught by L omega into sin omega t minus of your pi by 2. Actually it will be sin 90 minus theta. Removing the minus sign, I am writing in terms of sin of your omega t minus of your pi by 2 part of relation. Now see here, this L into omega is having a very peculiar property beta. This L into your omega is known as of your XL. XL is known as inductive reactance. This is known as of your XL. This XL will be equal to your L into your omega. So this XL is known as what beta? This XL is known as of your inductive reactance. Okay. Inductive reactance. Product of your inductor into your omega is known as XL. That XL is known as of your inductive reactance part of relation. That means I can write this formula as right now. I is equals to this will be V naught divided by your X into your L into sine of your omega t minus of your pi by 2. V naught by XL. XL is nothing but like resistor. XL is nothing but like your resistor. So I'm writing that one as I is equals to potential by resistor is nothing but maximum current. So that is nothing but I is equals to I naught. I naught is known as peak current into your omega t minus of your pi by 2. So this is your current whatever we are getting when it is been connected to your inductor part of relation. So when it is connected to your inductor part of relation, the current what I am getting is I is equals to I naught into sine omega t, and the alternating EMF is how much for me? V is equal to V naught into sine omega t. So if you see this equation number 1 and the final equation what we have written right now, this is equation number 2. So from 192 it is very clear that whatever the okay, so from equation 192 is very clear that there is a difference of your sine beta, that is sine omega t. Here it is sine omega t minus pi by 2. That means in only inductor voltage is leading the current, or current is lagging the voltage by how much beta? Pi by 2 part of relation. So I can say right now here, keeping a note, voltage leads to the current, voltage leads the current by pi by 2. Or else I can say that current lags the voltage, by pi by 2. Anything is fine beta. Very important conditions you need to remember. So when a current is been passing through the inductor, voltage leads the current by your pi by 2, or we can say that current lags the voltage by your pi by 2. Current lags the voltage by your pi by 2 part of relation. Very important. Voltage leads the current by pi by 2, or current lags the voltage by your pi by 2 part of relation. Okay, and make sure that even you can write this point. Inductive reactance plays a role of resistance. Its unit is ohm. So inductive reactance is nothing but what? Inductive reactance can play the role of your resistance, part of relation. That is very important point you need to remember for this one beta. Inductive reactance plays a role of your resistance, plays a role of resistance. Unit is nothing but for me ohm. Unit is nothing but for me ohm part of relation. That means when only pure inductor is being connected, in a pure inductor is being connected, or when inductor is connected to your alternating current, the voltage leads by pi by 2 or 90 degrees, or current lags by your 90 degrees, or current lags by your 90 degrees part of relation. So if I'm drawing in terms of a diagram for this one, see these diagrams you need to remember better. So here we are taking the potential, or we are taking the current I. On an x-axis we are taking the time t. Voltage is ahead kabatti, so this will be your voltage like this. So this will represents me capital V. Whereas current is lagging kabatti, it is lagging by how much better? 90 degrees kabatti. So this is something like this. Okay, so this is your current. Current is lagging by 90 degrees. Current is lagging by 90. That means in case of DC, inductor offers zero resistance because omega will be zero. But in AC, it offers a resistance of your XL part of relation. So I can take one point right now. In case of DC, in case of your DC, inductor offers, inductor offers, inductor offers zero resistance. Inductor offers zero resistance because there is no omega for that one. But in case of AC, alternating current kada, but in case of AC, it offers, it offers a resistance, it offers a resistance. XL is equals to L into omega. XL is equals to your L into your omega part of relation. Is that clear? Sure. Third one, AC through capacitor. AC through capacitor. So we are getting all the conditions. See what happens when alternating current is passing through resistor, what happens when alternating current is passing through the inductor, what happens when alternating current is passing through the capacitor part also. Like see here right now, I am taking a capacitor like this. This is your capacitor. To this capacitor, we are connecting an alternating source. We are connecting an alternating source. This is your capacitor. See this potential here V is equals to V naught into sine of your omega into t. So from here there is a flow of a current, that is nothing but I. This is a given condition. That means this potential is always common for me. V is equals to V naught into sine of your omega into t. This is always constant beta because this is the source which is being produced. Now see, when this is connected to the capacitor, this capacitor starts getting charged slowly. So this gets charged slowly. So what is happening to this one right now? It will get certain potential right now here. So charge is being storing in that one. So as it is getting charged, let's say for example, let at any time, let at your any time, say for example some t. Charge on capacitor is, charge on capacitor, charge on capacitor is say for example q. Ante kada, capacitor stores the charges. When you're connecting to alternating current, this current will be making this capacitor to get converted into a charge. So charge is getting stored in this one right now. So when charge is getting stored in this one, how do you calculate the charge? Q is equals to C into V. Or else I can write here C. V value already we got here. What is the source? V naught into sine of your omega into t. That means I can write here Q is equals to this C into V naught can be written as of your what? Q naught into sine of your omega into t. Now once I know the charge, I can calculate the current now beta. I is equals to dq by your dt because I need the relation between voltage and current. So that is equals to d into this one is your Q naught into sine of your omega t divided by your dt. So in this one, Q naught is a constant. Differentiation of sine is nothing but how much beta? Differentiation of sine omega t will be equal to how much? Can anyone tell me? So what is the differentiation of your sine of your omega t? Sine omega t differentiation enta. Omega is a variable kabatti. This one is omega into your cos of your omega t. So this is your cos of your omega into t. Is that clear? Is that clear? So V naught value is how much beta? Q naught value is equals to C into V naught Rosconoma. So this one is C into V naught into omega into your cos of your omega into T part of relation. Or else I can even write this one as of your V naught is your constant right now. So keep that V naught as it is divided by 1 by C omega. You take it down. So it is 1 by C omega into this one is your cos of your omega into T. So this is still written as of your V naught divided by 1 by C omega is nothing but of 1 by XC. This is cos omega t can be written as of your sine of your omega t plus of your pi by 2. Can I write like this? So this is your current. So V naught by XC is nothing but equal to how much beta? Here I is equals to XC is again the role played by the resistance beta. So V naught by R ankunte this will become for me your I naught into your sine of your omega t plus of your pi by 2. That means current is 90 degrees ahead right now. See, so this is the current what we are getting right now. This current I got I is equals to your I naught into your sine of your omega t plus of your pi by 2. I naught value is how much here? I naught value is V naught by your x into your C. What is your XC? Can anyone tell me what is XC beta? XC is equals to 1 by C into your omega, which is known as of your capacitive reactance, which is known as of what? Capacitive reactance. Capacity reactance. Uh, Capacity reactance, which plays a role of resistance, which plays a role of your resistance. Unit again for this one is nothing but of your ohm only beta. Ohm is the unit for this one. So XC is equals to 1 by C into your omega. XC is known as of what? Index capacitive reactance. This is known as of your capacitive reactance. XC is known as of your capacitive reactance, which plays again the role of your resistance. Now I can say that now if I see this equation number 2 and equation number 1, see this one. Equation 1 is sin omega t. Equation 2 is sin omega t plus pi by 2. That means who is ahead beta? Current is ahead. So I can say that, keep a note for this one. In capacitor only, in C, capacitor only, current leads to the voltage. Current leads to the voltage by pi by 2. Current leads to the voltage by how much? Pi by 2 bar. That means if I am taking this one like this, okay, so if this is your voltage right now, okay, on y-axis I'm taking the potential or current, on an x-axis we are taking the time t. So what is ahead beta? Current is ahead right now, so we'll be getting the current like this. So I'll try to draw with alternate current. So this will be your current here right now. Okay, so this one is your current and this one is your voltage. This one is your voltage. Now see, this is voltage and this is your current. So current is head now. So in DC, capacitor offers how much beta? Infinite resistance, because omega is again 0 for me for the given conditions. I can even write that point right now here. So in direct current, in DC circuits, capacitor offers infinite resistance, whereas in DC inductor offers how much resistance beta? Zero resistance. So in DC capacitor offers you infinite resistance because omega is equals to 0. But in AC circuits, it offers a resistance. What is that resistance? Xc is equals to 1 by C into your omega. Xc is equals to your 1 by C into omega. So AC circuit, in DC circuit, capacitor offers infinite resistance, but in AC circuits it offers a resistance part of relation. Very important relation, beta. So in AC circuit, what I can say, in capacitor only, current leads to the voltage by your pi by 2. Current leads the voltage by your pi by 2 part of relation. Is it clear for everyone? Is it clear for everyone? Okay, na? So once again, you see what happens when we are connecting to the simple AC circuits. What we are connecting? Alternating current. When alternating current is connected to the resistor, there is no phase difference. Voltage and current are in the same phase. That means when voltage is zero, current is zero. When voltage is maximum, current will be the maximum. But what happens when an alternating is current is being connected to your inductor? So when alternating current is being connected to the inductor, connected potential is V is equal to V naught into sine omega t. So simplifying it, I got current is equals to how much for me? I is equals to your XL into your sine omega t minus pi by 2. That means voltage leads the current by pi by 2, or current lags the voltage by your pi by 2. This is a diagram you need to remember, and we define one important term in this one is called as of your XL. XL is known as of your inductive reactance, which is very important term you need to remember for the given condition. XL is equals to your L into your omega part of relation. In the same way, when I'm talking about for the given conditions, when alternating current is passing through capacitor, where it is cutting current per capacitor, V is equals to V naught into sine omega t. Simplifying it in the basic conditions, we got I is equals to your I naught into your I is equals to how much for me? I naught into your sine omega t plus of your pi by 2. That means it is ahead. So in this one, this V naught by XL is known as of your I naught. This 1 by C omega is known as of your XC. XC is known as of what? Capacitive reactance. It is known as capacitive reactance, which plays the roles of your resistance. Okay, now so now in this one the current is ahead by 90 degrees, or voltage is 90 degrees lagging. That means in DC capacitors offers your infinite resistance. In direct current, capacitor offers your infinite resistance, but in AC it offers certain resistance part of relation. So you need to remember this relation, and XC is equals to 1 by your C into your omega. Is that clear for everyone? Chalo, let me write a point here. What we have learned. What we have learned in today's session of a class, what we did in an AC circuit, if I'm talking about, in an AC circuit, in an AC circuit, let V is equals to how much, beta? V naught into your sine of your omega into t, and current I is equals to your I naught into your sine omega t plus of your phi. So where I naught is known as beta, I naught is equals to your V naught by your resultant resistance. That I'm representing it by your Z here, beta. What is a phi here? Phi is known as of your phase difference. Phi is your phase difference between your voltage and current. Voltage and current. And Z is known as of your impedance. Z is known as of your impedance. Z is known as impedance. And it plays the role of what, beta? Resistance. It plays the role of resistance. It plays the role of resistance, and unit is ohms. Unit is nothing but for me ohms part of relation. Okay, so what I can write here, when R is connected, number one. So number one, this is number two, this is number three. When only R is connected, only R only is connected. L only, when inductor only is connected, when only capacitor is connected. Okay, so what is the value of your Z and what is the value of your phi? Okay, now when only R is being connected, Z value is equals to R, phase difference is equals to 0. When only L is being connected, this will be XL is equals to L into your omega, and phi is equals to your how much for me? Minus of your pi by 2. When only C is being connected, XC is equals to 1 by your C omega, and this will be equal to your plus of your pi by 2. Okay, so this is a thing you need to remember. When alternating current, when only resistor is being connected, impedance is equals to R and phase difference is 0. When alternating current is connected to inductor, XL is equals to L omega and phase difference is minus pi by 2. When alternating current is connected to capacitor, XC is equals to 1 by C omega and the phase difference is how much for me? Your plus of your pi by 2 part of a relation. Is that clear? So while doing the problems, make sure that you treat XL and XC as of your resistance beta and try to simplify it like a series and as well as of your parallel combination part of relation. Like say, if I'm writing here right now, potential across like VR is equals to I into your R. The same way, potential across your inductor will be equal to your I into your XL and potential across your capacitor will be equal to your I into your XC part of relation. So treat the inductor and the capacitor as a resistance and try to simplify the problems part of relation. Like if I need to write the current through resistor, current through resistor will be equal to how much beta? V by R. Current through inductor will be equal to how much beta? V by your XL. If I need the current through the capacitor, that will be equal to your V by your X into C. So just like of your series and parallel combination, you try to do the problems part of relation. Okay, now in series circuit, add the voltage like vectors and plot the current along your x-axis, and VR will be voltage along your x-axis. VR voltage, VR will be along your positive x-axis. VL leads the current by your pi by 2, plot it along your positive y-axis, and VC will lag the voltage by pi by 2, so plot it along your negative y-axis part of relation. So I can write here how to solve an AC circuit problems. Method to solve AC circuits. Method to solve your AC circuit. So what I did, I told you right now, treat inductor, and capacitor as a resistance, equal to XL and XC. Okay, the series and parallel comes, apply same series and parallel combination for that one. Apply same logic of series and parallel. Series and parallel. In series, what remains constant? Current. And in parallel, what remains constant? Potential. Accordingly, you can write it out. So in series circuit beta, this is very important. In series circuit, vectors idea ఉంది కదా, vectors ఎలా యాడ్ అవుతున్నా అలానే యాడ్ చేయండి బేసికల్. Add voltage like of your vectors. Add voltage like vectors. Add voltage like of your vectors. So what you do is plot current along x-axis. So what are you doing? We are plotting the current along your x-axis. So potential across resistor VR will be along x-axis. Why? Because they are in same phase, isn't it? Whereas potential of your inductor VL will be, it is leading the current by how much beta? Potential across the inductor will be, so it is VL. So I can write here right now, potential across your inductor VL leads the current by pi by 2. So plot it on positive y-axis. Okay, and third one is of your VC. So what is happening in VC beta? VC lags the voltage. Okay, VC is lagging the voltage by your pi by 2. Okay, VC lags the voltage and VL leads the current by pi by 2. VL lags the voltage by your pi by 2 parts. What do you do it? Plot it along negative y-axis. Plot it along your negative y-axis. Find the net voltage along your y-axis, then combine VR and V net along y-axis by the vector addition particulation. So it is a simple logic we need to apply for this one. So next one is find net voltage. I'll tell you how to do in the problems also. So find the net voltage along y-axis. Net voltage along your y-axis particulation. Then combine VR and net voltage on y-axis by vector addition, by your vector addition. Okay, now మనకి ఇది already idea ఉంది కదా. Like if this is a one vector here right now, this is your P vector and this one is like of your Q vector. Resultant of this one is given by this one. So this is your resultant vector, that is nothing but of your R bar, which is making an angle of your theta. So here R bar is equal to how much beta? Under root of your P square plus of your Q square. And what is the value of tan theta? Tan theta value will be equal to perpendicular by your base. So it is your Q divided by your P particulation. So the angle between the resultant and voltage, this is nothing but theta. Theta is the angle between what beta? Theta is your angle between what beta? Resultant voltage and current. Resultant voltage and current, because we are taking the current on x-axis and the current particulation. Okay, which gives the phase difference between voltages and current beta. Okay, which gives the current voltage. That means the angle between the resultant voltage, the angle theta is the angle between the resultant voltage and current, which gives phase difference, which gives your phase difference between voltage and current, come back again once again here beta chudandi. So whenever we are getting series circuit ante ippadi we have taken only one resistor, one inductor, one capacitor. If I take the both of them in series or both all the three in the series, so whenever you are doing in series combinations, you just add like of a vectors beta. What you do is first plot the current along your x-axis. So current should be plotted along your x-axis particulation. See how I am drawing the voltages here right now. This is your graph and this is your x-axis. ఈ ఒక్క గ్రాఫ్ గుర్తుపెట్టుకుంటే అన్నీ వచ్చేస్తాయి నన్ను. On your x-axis, what I am taking? Current. So now see, first one, if I am going for the first one, that is nothing but when alternating current is passing through resistor, what is the phase difference between voltage and current? Voltage and current are in the same phase. That means for this one I can write here potential across your resistor is along your current. Phase difference between them is 0. అంతే కదా, potential across resistor and current, both of them are in the same direction. Now say next one, potential across your next one is how much for me? Inductor. Antena. Second one is inductor. Now see, inductor sin omega t, current is minus of sin omega t. That means current is lagging by minus of pi by 2. That means when it is lagging means potential will be ahead kada, kabatti I'll be writing here potential of your inductor, that is nothing but VL in the upward direction. Now in the same way, if I am going right now for the capacitor, it is ahead by your what? Pi by 2. Ante chudandi, see here, when alternating current is passing through capacitor, this is the potential and current how much I am getting? Pi by 2. That means current is 90 degrees ahead. Ante potential will be 90 degrees lagging. That means this is your VC. So this one is your 90 degrees and this one is also your 90 degrees. So with respect to current, potential of the inductor is 90 degrees ahead and with respect to your current, potential of a capacitor is 90 degrees lagging. Is that point clear for everyone beta? Is the diagram, vector diagram clear for me? ఇది అర్థమైంది అందరికి? ఇది అర్థమైతే మిగతావన్నీ ఈజీగా అయిపోతుంది మనకు. అర్థం కాకపోతే ప్లీజ్ ట్రై టు టాక్ మీ, ఐల్ హెల్ప్ యూ అవుట్. So whenever you are doing the problem, just do like a vectors. What you'll take the current on your x-axis and try to write the voltages along your x-axis and y-axis. When it is passing through inductor, when it is passing through resistor, there is no phase difference kabatti potential across resistor and current are in the same. Potential across inductor is 90 degrees ahead, potential across capacitor is 90 degrees lagging. Ante kada? Is that clear for everyone? Ikkada chudandi, I have written that point here right now. When alternating current is been passing, so the current leads the voltage by your pi by 2, or else you can write one point here, r opposite point could raskochu kada. Current leads the voltage of your pi by 2, or voltage lags by 90 degrees. Avuna kada? That's what we have taken right now. Is that graph clear for everyone? Is this graph clear for everyone? Is this graph clear for everyone? Chapala. Is this graph clear for everyone? Z is the same rule as of inductance and phi is the phase difference. Clear anandarki? When current is passing through your capacitor, alternating current is connected to capacitor, phase difference is pi by 2. That means the current is 90 degrees ahead or voltage is 90 degrees lagging. If any phase difference with respect to current none. The diagram clear andarki? And Satvik, Danish,
Clear, sir.
clear mala sa cheppana?
అర్థమైంది సార్.
Okay, chalo. So let us try to go now for the series combination beta. Series AC circuit. Series AC circuits. Series AC circuits. Okay. So just add voltages like vectors beta. So I'm writing that point here right now. Add voltages like vectors. It will be easy for your problem solving ability. So the first one is number 1, LR circuit. First one is your LR circuit. Okay. So when current is passing through LR circuit, are also called as of your RL circuit. Anything you can write, there is no problem. LR circuit or RL circuit. LR చెప్పడం ఈజీగా ఉంటుంది కాబట్టి నేను LR అని రాశాను. or else you can write it as also R and L particulation. That means in this one there is a resistor, and there is also your capacitor. Both of them are in series. Now both of this one are being connected to your alternating source of your EMF particulation. So that is your V is equals to V naught into sine of your omega into T is always constant. This is your resistor and this is your inductor. So there is a flow of a current in this one that will be equal to your I. So I is equals to how much beta? I is equals to your, this is the potential across your inductor, this is the potential across your resistor, and this is your potential across your inductor. Okay now. So now tell me this V is equal to how much for me? V naught. So V is equals to your V naught into sine of your omega into T. Potential across your resistor is how much beta? I into your R. Potential across your inductor will be equal to how much beta? I into your XL. This all things equations I told you. Now, if I am writing the vector for your VR and VL, ela undi cheppandi. See, VR and VL are perpendicular to each other. So can I write like this, the diagram for this one? Voltages, if I'm taking for both of them, this will be something like this. So here there is your y-axis and this one is along your x-axis. So this is a potential across your resistor, this is the potential across your inductor. Resultant of that one is being given by this one. So this is your resultant potential and this is making an angle of your phi, and this one is your resultant. So if I'm taking like this and this one is your like this, isn't it? And on x-axis, what we are taking, beta? Current. On x-axis, we are taking your current part of relation. Now, can anyone tell me how do you write the value of V, beta? Just like a vector addition, V is equals to under root of your VR square plus of your VL square. అవునా కదా? So in this one, if I'm writing this relation, so V is equals to under root of your VR is equals to how much, beta? I into your R, this one is your whole square, plus this one is your I into your XL, this one is your whole square. I square బయటికి తీసుకొచ్చేసండి. So this will become for me I. This one will be under root of your R square plus of your XL square. Okay, now XL can be written as right now. So this is your potential. So V is equals to I into this one is under root of your, this one is your R square plus XL is equals to your L square into your omega square part of relation. So this is your potential. V is equals to your R, or else V is equals to I into under root of your R square plus XL. XL is known as of your inductive reactance. Today only you try to go through your IP material and learn the definitions of this one better. There are also 2 more questions for your board examination. How do you define an inductive reactance and how do you define an inductive capacitive reactance, blah blah conditions right now. So I got the value of this one. So V by R is nothing but equal to how much, beta? Can anyone tell me what is V by I, beta? Here V by your I is equals to under root of your R square plus of your L square into omega square. V by I is nothing but Z. Z is known as impedance. So impedance is Z is equals to your R square plus of your XL square. XL square. So this is known as of your impedance. Z is equals to under root of your R square plus of your XL square. Is that clear for everyone? Then what is the value of phi, beta? From the given figure, I can write tan phi is equals to, this will be VL, this will be VR. So I can write here tan phi is equals to how much? Tan phi will be equal to, tan phi is equals to potential of your inductor divided by potential of resistor. So that will be equal to your I into your XL divided by I into your R. This I gets cancelled. So tan phi is equals to your XL divided by capital R. Okay, now, or else I can write here tan phi is equals to XL is equals to how much for me? L into omega divided by capital R part of the relation. So ultimately I got your phase angle when alternating current is being passing through your LR circuit. When alternating current is being passing through your RL circuit or LR circuit, the potential what I'm getting is right now here. Can I write the potential, beta? Potential, how do you write here right now? V is equals to V is equals to your I into your R part of relation. That means voltage leads the current. So you see the vector diagram right now in this one. So if I see the vector diagram, చూడండి ఈ పొటెన్షియల్ ఈ కరెంట్ కంటే 5 degrees ahead లోనే ఉందా? So I can write that point right now here. Keep it a star mark and write voltage resultant voltage leads the current by 5, leads the current by your 5 part of relation. Is that clear? Is that clear? If voltage is leading the current by 5, so what will be the current, beta? I is equals to your I naught into your sine of your omega t minus of your 5. It will be lagging by your 5. అంతే కదా? If potential is ahead by 5, current will be lagging by your 5. So current will be I is equals to I naught into sine omega t minus 5, where I naught value is how much? I naught value is equals to V by your Z part of relation. So I is equals to your I naught into your sine of your omega t minus 5. So voltage leads the current by your 5. Is it clear? Is it clear? So this is V naught. Okay na? No doubt unda indla. See, this voltage is ahead by how much beta? 5 kada. Ahead by your 5. So V is equals to V naught into your sin omega t plus 5 rayala. Current is lagging by your 5. That means this voltage I can write here. V is equals to V naught into sin omega into t plus 5. Omega into t plus of your 5. It is 5 angle ahead. Okay na? అర్థమైంది ఇది అందరికి? What happens when alternating current is passing through your LR circuit? Just write that one and write the vectors and take the vector diagram. That's it better. Nothing else is there in that one. Okay. Next one, me try cheyandi andaru okasari. Second one, alternating current through AC through. What is another one I can take? RC circuit. Another one I can take is RC circuit. What happens when alternating current is passing through RC circuit? That means there is a resistor for me and there is also a capacitor for me, and this both of them are connected to your alternating source of your EMF. Alternating source of your EMF. So this V is equals to your V naught into sine of your omega t. This one is your R and this one is your capacitor. There is a flow of a current that is nothing but of your I part of relation. So known source of EMF kabatti ikkada vachesi potential vachesi VR and ikkada vachesi potential emo across capacitor. You know that potential across the capacitor is lagging. So I can write here V is equals to your V naught into sine of your omega into t, and current through resistor will be equal to how much for me? Potential through resistor ganaka raskunte potential through resistor is equals to I into your capital R. Potential through the capacitor will be equal to your I into your XC, isn't it? So if I draw the vector diagram for this one, so this will be something like this. This is your origin O. So here I am taking your current. So potential across your capacitor. This one is your V into R, and here it is your potential across your capacitor. So resultant will be something like this, and this is making an angle of your 5. So this is your vector diagram. So this is the resultant kada. So this resultant can be calculated by the formula V is equals to under root of your, this will become for me VR square plus of your VC square. So that will be equal to under root of your VR is nothing but of your I into your R whole square plus this one is I into your XC whole square. So potential V will be equal to I, you bring it out better. So this will be under root of your R square plus of your XC square, isn't it? Or else I can write this one also equal to V is equals to I under root of this one is nothing but R square plus XC is your XC is equals to your how much for me? 1 by C omega whole square. 1 by C omega whole square or C square omega square. Now V by I, if I am writing again, that will be equal to your how much? Z. So the impedance for this one will be equal to your, this one is your under root of your R square plus 1 by C square omega square. That means impedance Z will be equal to under root of your, this one is your R square plus 1 by C square into your omega square. So this is the resultant impedance or resultant resistance when alternating current is being passing through your RC circuit part of relation, and the Z will be equal to this much and the potential will be equal to V is equals to your I into your R square plus 1 by C into your omega part of relation. Now if I need to calculate the value of your tan phi beta, how do you calculate the value of tan phi? So tan phi will be equal to your VC divided by V into your R. VC is equals to I into your XC divided by I into your R. I and I gets cancelled. So tan phi will be equal to your XC by your R. Or else I can write tan phi is also equal to 1 by XC. See, XC is 1 by C omega into your R part of relation. So this will be your phase angle. Or else this can be written as of your phase angle part of relation. Okay. So phase angle is equal to how much for me? XC by R, or tan phi is equal to 1 by C omega into your R part of relation. Clear for everyone? Is it clear for everyone? That means current is leading the voltage by how much better? If you see the diagram clearly right now, so this current is leading by your 5, or voltage is lagging by your 5. I can say that point from the diagram. I can say right now, current leads the voltage. Current leads the voltage by 5. Voltage by 5. That is, I is equals to I naught into your sine omega t plus of your 5. This is your current. So this is your current part of relation. So it is ahead of this one. I is equals to your I naught. That means current leads by your 5 part of relation. Clear for everyone? In the previous case, current was lagging. Current was your lagging part. This one was of a current. I is equals to your I naught. Sorry. So this one was your current. I is equals to I naught into sine omega t, where I naught is V by Z. So voltage leads the current by your phi, or else I can say current is lagging by this given condition. Is it clear for everyone? Okay now. Chalo. So what is left out now, beta? Can anyone tell me? మన దగ్గర ఇండక్టర్, రెసిస్టర్, కెపాసిటర్ ఉన్నాయి. రెండు అయిపోయినాయి. ఇంకోటి ఏమైనా మిగిలి ఉందా మనకు? LNC తీసుకుందాం ఇప్పుడు రైట్ నౌ. Third one is your LC circuit. AC through your LC circuit. The alternating current through LC circuit. What happens when alternating current is been passing through your LC circuit part? Can anyone tell me? First draw the inductor, then draw your capacitor, then connect both of them to your alternating source of your EMF. Okay, that means here whatever the potential I'm having, V is equals to V naught into sine of your omega t, and this is your L, this is your C. So this will be the potential across inductor, and this will be the potential across your capacitor. Okay, so V will be equal to how much beta here right now? V is equals to here, V is equals to V naught into sine of your omega into your t. Potential across inductor is equals to I into your XL. Potential across your capacitor is equals to I into your XC. Isn't it? Now tell me how VL and VC are connected, beta? Can anyone? How VL and VC are connected? On x-axis, we are taking the current, that is nothing but of your I, and this is your origin. You know that we are having the potential of your inductor above, and we are having the potential of the capacitor down. Angle between them is how much? V, 180 degrees. So how do you calculate the net beta? Can anyone tell me how do you calculate the net? If it is about 10 down 5, you will do 10 minus 5 now. That means VL minus of VC. That means effective potential will be equal to your VL minus of your VC. V is equals to VL minus of your VC part of relation. Or else I can write from this one, V is equals to I into your XL minus of your I into your XC. So V is equals to I common. This one is your XL minus of your XC. So this will be equal to your XC. So or else I can write here V is equals to your I. XC is how much for me beta? So I can write even this one as of your V by your I is equals to V by your I is equals to XL minus of your XC. V by I is nothing but what beta? Impedance. So this will be your Z. Z is equals to your XL minus of your XC. So this will be the resultant impedance of the given condition. Okay, so V is equals to your VL minus of your VC part of relation, or else I can write still by this relation right now. Z is equals to XL is nothing but how much? L omega minus of 1 by C into your omega. So omega is also equal beta in terms of frequency. Omega will be equal to 2 pi into your F, or else 2 pi by your capital T. That depends upon the problem. You can write it for the given conditions part of relation. Now, what is the phase beta? What will be the phase? Can anyone tell me what will be the phase? XL minus of your XC. Phase difference ఎంత వస్తుంది? ఎంత అవుతుంది అన్న?
ఆసిఫ్ సార్
సార్
ఒక్క ఒక్క నిమిషం సార్, ఒక్క ఇన్ఫర్మేషన్ చెప్పాలి వీళ్ళకి.
సార్ చెప్పండి.
ఏమో ఒకసారి ఎన్ఐజెడ్ పిల్లలు వినండి, N120 ఎన్ఐజెడ్ పిల్లలు. మీరు ఎవరైతే బోర్డు ఫార్వర్డింగ్ హైత్ నగర్ నుంచి ఉన్నారో బాబు, వాళ్ళు మీరు జేఈ మెయిన్స్ కి అప్లై చేసేటప్పుడు హైత్ నగర్ అడ్రస్ పెట్టండి. కాలేజీ అడ్రస్ అడిగినప్పుడు మీరు హైత్ నగర్ అడ్రస్ పెట్టండి. సరే, హైత్ నగర్ అడ్రస్ కూడా నేను మీకు వాట్సాప్ గ్రూప్ లో సెండ్ చేస్తా, 301 300 గ్రూప్ లో. కాలేజీ కోడ్ వచ్చేసి 58395, నారాయణ జూనియర్ కాలేజ్, సాహెబ్ నగర్, హైత్ నగర్, రంగారెడ్డి డిస్టిక్. ఈ అడ్రస్ ఇవ్వండి మీరు. హైత్ నగర్ నుంచి ఎవరైతే, అంటే మీరు ఎన్రోల్మెంట్ ఎగ్జామ్ రాశారు అక్కడ ఆల్రెడీ. ఎన్రోల్మెంట్ ఎగ్జామ్స్ కి ఒక 107 మెంబర్స్ నేనే తీసుకెళ్లి ఎగ్జామ్ రాయించాను హైత్ నగర్ కాలేజీలో. వాళ్ళు ఎవరైతే ఉన్నారో వాళ్ళందరూ మీరు జేఈ మెయిన్స్ కి అప్లై చేసేటప్పుడు కాలేజ్ అడ్రస్ నారాయణ జూనియర్ కాలేజ్, హైత్ నగర్, రంగారెడ్డి డిస్టిక్ అని ఇవ్వండి. నేను అది అడ్రస్ మీకు వాట్సాప్ గ్రూప్ లో కూడా సెండ్ చేస్తాను. ఇంకెవరైనా అప్లై చేస్తుంటే, ముందు తెలియక అప్లై చేస్తుంటే, మీకు అప్లికేషన్ అయిపోయిన తర్వాత ఎడిట్ ఆప్షన్ ఇస్తాడు. ఆ ఎడిట్ ఆప్షన్ ఇచ్చినప్పుడు మీరు అడ్రస్ మీరు చేంజ్ చేసుకోండి. ఇంకెవరైనా పర్సనల్ గా ఏమైనా డౌట్స్ ఏమైనా నాకు కాల్ చేయండి. ఈ క్లాస్ డిస్టర్బ్ చేయొద్దు. సార్ థ్యాంక్ యూ సార్.
Okay sir. Now see this one beta. Alternating current through your LC circuit beta. Inductor and capacitor నుంచి ఒక alternating source connect కనుక అయితే, now see this is current. With respect to current, the angle made by the voltage is 90. With respect to current, the angle made by the capacitor is VC. ఇప్పుడు దీనిలో నేను ఇది పెద్దది అనుకున్నాను. ఇది పెద్దది అనుకున్నప్పుడు ఏం రాస్తున్నాను? VL మైనస్ VC. ఒకవేళ కిందది పెద్దది అనుకోండి, కిందది మైనస్ పైన రాసుకుంటా. అందుకోసం ఇక్కడ నేను ఆల్మోస్ట్ అని రాశాను చూడండి. So VL is greater than VC. This is the condition. Otherwise, you can write VC minus of your VL also for the given condition. Okay, now. So what is the phase angle beta? Z is equal to XL minus of your XC. So phase will be equal to your how much? Phase angle will be equal to your pi by 2. Phase angle will be equal to pi by 2. Now very important here, right? No. Okvela, if your XL is greater than of your XC, XL is greater than of your XC, then voltage leads the current, by 90 degrees, pi by 2. Okay, in the same way, if your XC is greater than of your XL, okay, so then current leads the voltage, by your pi by 2. Okay, this is a very important point. Depending upon which is lag, which is ahead, దాని ప్రకారం మనం ఈక్వేషన్ రాసుకుంటా పోతాం బేసిక్గా. ఒకవేళ రెండు సేమ్ అయినాయి అనుకోండి, ఇఫ్ యు సే మీ సార్, ఇఫ్ XL is equals to your XC, inductive reactance is equals to capacitive reactance, then XL is how much? Omega into L. XC is how much? 1 by C into your omega. అవునా కదా? So this omega and omega will go here right now. So this will become for me omega square, that is equals to 1 by L into C. So square root ni తీసేసుకుంటే omega is equals to 1 by under root of your L into C. దీన్ని మనము resonant frequency అంటాము. This is known as what? A resonant frequency. This is the condition for resonance condition. This is the condition for resonance. This is the condition for your resonance. Resonance and XL must be equal to your XC. So omega naught is known as resonant frequency. Omega naught in etla kuda raskovachu nanu. So omega naught is nothing but 2 pi into your frequency is equals to 1 by under root of your L into C. అంటే resonant frequency ఎంత అవుతుంది అన్న? Resonant frequency F naught will be equal to 1 by 2 pi into under root of your L into C. ఇట్లా కూడా రాసుకోవచ్చు. This frequency is known as of your resonant frequency. Resonant frequency. What do you mean by resonant frequency? Resonance అంటే ఏంటి? Same. If inductive reactance is equal to capacitive reactance, then Z ఎంత అవుతుంది? Z will become for me 0 and current will become for me infinity. అంతే కదా. ఈ కండిషన్ లా ఇఫ్ ఎక్స్ఎల్ ఈజ్ ఈక్వల్స్ టు యువర్, ఈ కండిషన్ లో కరెంట్ ఎక్కడ పోయింది, వోల్టేజ్ లో మనకు వి ఈజ్ ఈక్వల్స్ టు, ఈ రెండు ఈక్వల్ అయినాయి అనుకో, ఎక్స్ఎల్ ఈజ్ ఈక్వల్స్ టు యువర్ ఎక్సి, isn't it? XL is equals to your XC, ఇది అయిపోయిందంటే ఇది క్యాన్సిల్ అయిపోతుందా. సో కరెంట్ విల్ బి ఈక్వల్ టు హౌ మచ్ ఫర్ మీ, ఇన్ఫినిటీ, అంటే ఈక్వల్ టు యువర్ పొటెన్షియల్. పొటెన్షియల్ పెరిగే కొద్దీ నీకు వెళ్ళిపోతూనే ఉంటుంది. అండ్ ఇంపిడెన్స్ విల్ బికమ్ ఫర్ మీ హౌ మచ్, జీరో కదా. V by I is nothing but of your Z. If this is same, so impedance will become for me zero. That means if resistance is zero, then the current will become how much for me, infinity. Current will become for me infinity part of relation. So we are having two graphs for this one, you need to remember better. So if I'm drawing the graph current versus your frequency. సో గ్రాఫ్ ఎలా వస్తుందంటే ఇనీషియల్ గా ఇక్కడ నుంచి రైజ్ అవుతుంది, it will attain a resonant frequency, that is nothing but of your omega naught. Again from there it will be dropping like this. Okay, so that is your current versus your omega diagram. If I am drawing the diagram for your like this, this is your y axis and x axis, this is your z axis versus omega. So what is happening, z is initially maximum kabatti, from maximum value it will come down. At resonant frequency it almost all becomes for me zero, it almost all becomes for me zero. Again from there it will be rising. So this is your omega is equals to your omega naught, z versus omega, this will be the graph for that one. ఈ గ్రాఫ్ ఖచ్చితంగా గుర్తుపెట్టుకోవాలన్నా, బికాస్ దే ఆర్ ఇన్వర్స్లీ ప్రపోర్షనల్ కాబట్టి రెక్టాంగులర్ హైపర్బోలా, ఇది మాక్సిమం నుంచి రెసొనెంట్ ఫ్రీక్వెన్సీ కాడ జీరో అయిపోతుంది. అగైన్ ఫ్రమ్ రెసొనెంట్ ఫ్రీక్వెన్సీ ఇట్ విల్ బి ఇంక్రీజింగ్ ఫర్ ద గివెన్ కండిషన్. So we got the alternating current through your series circuit, through your LR circuit, RC circuit, and your what do you call that one, L and C circuit. అవునా కదా. ఇంకేమైనా మిగిలిపోయి ఉన్నాయా, ఇంకేమైనా కాంబినేషన్ చేయొచ్చా సార్, ఆలోచించండి. ఇంకేమైనా కాంబినేషన్ చేయొచ్చా, మన దగ్గర ఏమేమి ఉన్నాయి, ఆర్ ఉంది, ఎల్ ఉంది, సి ఉంది. ఈ రెండు మధ్యలో కాంబినేషన్ అయిందా, ఈ రెండు మధ్యలో కాంబినేషన్ అయింది, ఈ రెండు మధ్యలో కాంబినేషన్ అయింది. ఇంకేమైనా కాంబినేషన్ చేయొచ్చా, ఇంకేమైనా కాంబినేషన్ చేయొచ్చా, ఇంకేమైనా కాంబినేషన్ చేయొచ్చా చూడండి ఒకసారి. చెప్పాలా, రెండు రెండు తీసుకున్నాం కదా, మూడు ఒకటేసారి తీసుకుంటే సిరీస్ కాంబినేషన్ అవుతుందా లేదా, ఆర్ఎల్సి మూడు ఒకటేసారి తీసుకోవచ్చా. సో వీ కెన్ టేక్ వన్ కంప్లీట్ రైట్ నౌ. ఫోర్త్ వన్ ఈస్ ఏసీ త్రూ LCR circuit, AC through your LCR circuit, alternating current through your LCR circuit. Ante we'll be connecting right now here one resistor, we will be connecting one resistor, then we'll be connecting one inductor, and we also connecting one capacitor. ఇవన్నీ మూడు సిరీస్ కాంబినేషన్ లా we are connecting it to your alternating source, we are connecting it to your alternating source. So this is your capacitor, so this is your capacitor, this is your inductor, this is your resistor. So we'll be getting the potential. So this one is the potential across your resistor, this is the potential across your inductor, and this is the potential across your capacitor. Potential across these alternating sources, V is equals to V naught into sine of your omega into T. Now what are the given conditions you T right now here? First point is we know the relation V is equals to V naught into sine of your omega into T. Potential across your resistor will be equal to I into your R. Potential across your inductor is equals to I into your XL. Potential across your capacitor will be equal to I into your XC. Okay, so alternatively we are assuming a condition right now, assuming V of L is greater than Vc, that is XL is greater than of your XC. Okay, so now how do you draw the diagram for this one, you see. So here we are drawing the diagram right now for this one like this. On x-axis I told you it will be taking current. On y-axis here we'll be taking as potential across inductor, down we'll be taking the potential across capacitor, and here we'll be taking the potential across your resistor. And this is your O. On y-axis we are taking the voltage, isn't it? On x-axis we are taking the current. VL is greater than VC అంటే దీని రిజల్టెంట్ మొత్తం పైకి వెళ్తుందా? So I can draw this diagram something like this. I can make this diagram something like this. See here. Can anyone tell me? VL is greater than V3 కాబట్టి ఇక్కడ ఏమైపోతుంది? VL minus VC ఇక్కడ అయిపోతుంది, and this one is your VR in this direction. So this vector is in this direction and this vector is in this direction. So this is your origin. Then resultant వచ్చేసి ఇక్కడ. So ఇది వచ్చేసి V and this is making an angle of your phi. Okay, no? So on x-axis we are taking current, and y-axis we are taking the potential, and this is your phi. Ante kada? Now calculate the value of your V beta. So V will be equal to how much for me? Under root of angle between them 90 degrees kabatti. This will be VR square plus of your VL minus of your VC whole square. Antena? So I can still simplify this one right now. So this is your potential. V is equals to under root of your VR square plus VL minus of your VC whole square. So I can write this one as V is equals to under root of your VR is how much beta? I square into your R square plus this one is your this one is I into your XL minus of your I into your XC whole square. అవునా కదా? సో ఇందులో కూడా I square కామన్ తీసుకోవచ్చా? So this will be equal to your I square ganaka common తీసుకుంటే this will become for me under root of your this one is R square plus of your XL minus of your XC whole square. So this will be the potential. V is equals to your I square బయటికి వచ్చేస్తుంది కాబట్టి ఈ స్క్వేర్ రాదు ఇక్కడ. సో ఈ స్క్వేర్ will get cancelled. అంతే కదా? ఈ I square బయటికి తీసుకొచ్చేసాను నేను. So that will not come right now there. So V will be equal to your how much for me? V is equals to your I into under root of your R square plus XL minus of your XC. Now if I'm writing V by I out right now, so V by your I is equals to your under root of your this one is your R square plus of your XL minus of your XC whole square. V by I is nothing but of your Z. So Z is equals to your under root of this one is nothing but of your R square plus this one is your XL minus of your XC whole square. This is your impedance. So Z is equals to your under root of your R square plus of your XL minus of your XC part of relation. అదే విధంగా tan phi రావాలంటే చూడండి దీంట్లోంచి tan phi అంటే this side by this side కదా. This one is VL minus VC. This one is nothing but of your VR. So I can write from the given figure tan phi will be equal to your how much? Tan phi is equals to VL minus of VC divided by your VR. That means I can write here I into your XL minus of I into your XC divided by I into capital R. Everywhere I gets cancelled. So tan phi will be equal to your XL minus of your XC divided by your capital R. So that is the value of your tan phi. So tan phi is equals to your XL minus of your XC divided by capital R part of the relations. These are the relations you need to remember. Now let us try to make some applications of this one beta. Number one, if XL is greater than XC, that means resistance of inductor is greater than resistance of your capacitor, then voltage leads here right now. So voltage leads the current. Voltage leads the current by your phi. Ante kada? Isn't it? So here I can write here current I is equals to your I naught into your sine of your omega t minus of your phi. The second way, if your XC is greater than of your XL, then current leads the voltage. Current leads the voltage by phi. Current leads the voltage by your phi. So where phi will be equal to how much beta? Tan phi will be equal to your how much right now? XC minus of your XL divided by your R. అవునా కదా? That means current will be ahead. So అప్పుడు current ఏమైపోతుంది? I is equals to your I naught. Current leads the voltage by your phi part of relation. So if XC is greater than XL, current leads the voltage by your phi. So what will be the current right now? I is equals to your I naught into your sine of your omega t plus of your phi. So where I is equals to how much for me? I is equals to your V naught divided by your Z. I is equals to V naught by your Z part of relation. And third condition, if XL is equals to your XC, then phase difference will become 0. So I can say right now, voltage and current are in same phase. Voltage and current are in your same phase. So when XL is equals to your XC, that means condition for resonance. Condition for your resonance. I already told you. So resonant frequency will be getting 1 by 2 pi under root of your L into C. So this will be your resonant frequency. And unit for this one is how much beta? Hertz. Unit for this one is nothing but hertz. So FR is known as what? Resonant frequency. Resonant frequency. And omega R is known as of your resonant angular frequency. Resonant angular frequency. అంటే ఇక్కడే రాశాను కదా ఇంతకు ముందు నేను ఎల్సి సర్క్యూట్లో ఎక్కడ రాశాను ఇక్కడ ఈ రెజొనెంట్ ఫ్రీక్వెన్సీ ఒమేగా ఆర్ అని రాయొచ్చు లేకపోతే ఒమేగా ఆర్ అని కూడా రాసుకోవచ్చు. ఒమేగా ఆర్ ఇస్ నోన్ యాజ్ ఆఫ్ యువర్ రెజొనెంట్ ఫ్రీక్వెన్సీ. ఓకే, రెజొనెంట్ యాంగులర్ ఫ్రీక్వెన్సీ పార్టిఫిలేషన్. Okay, that means in series resonance, impedance of a circuit is minimum and equal to how much beta? Z is equals to your R part of a relation. So I can write that point also here right now. In series resonance, XL is equals to XC అయిపోతే impedance ఎంత అవుతుంది నాన్న? Z is equals to your R and current is maximum. Infinity అని రాసుకున్నాము. Current is your maximum. Okay, so impedance in the circuit is minimum and it is equals to how much per minute? In resonance, in the series resonance, Z is equals to R. That means it will be your minimum. It will be your minimum and current is your maximum. So if I draw a graph for this one, we will be getting something like this. So this is your current versus your omega graph. The graph is something like this. It slowly increases, becomes maximum at resonant frequency. Again, it will try to drop. So this is the resonant frequency. This is your resonant frequency. Omega is equals to omega naught. And here the current is becoming for me maximum. That maximum current is I naught max will be equal to your V naught divided by your R. Okay. దీనిలో ఏం లేదు. ఈ ఎక్సెల్ లా మనం ఏం చేస్తున్నామంటే ఇక్కడ ఈ రిలేషన్ వచ్చింది కదా. సో ఈ రిలేషన్ లా ఇఫ్ దిస్ బోత్ ఆఫ్ దెమ్ ఆర్ ఈక్వల్ దెన్ V will be equal to under root of VR square కదా. So V is equals to I into Z రాస్తాము. V is equals to I into Z, that will become I into your R. ఈ I gets cancel అయిపోతే Z is equals to R అయిపోతుంది. So that is the condition at resonance condition. రెజొనెన్స్ కండిషన్ లో ఈ రెండు ఈక్వల్ అయిపోతే V will be equal to VR. V is equals to I into Z, this is equals to I into R. IA gets cancelled, so V will be equal to your Z part of relation. Adhe vidhanga you can write the different conditions. So if your XL is greater than of your XC, voltage leads the current by your phi. The same way, if XC is greater than of your XL, then current leads the voltage by your phi. Current leads the voltage by your phi part of relation. So I is equals to ikkada lead kada. Lead కాబట్టి ఇక్కడ ఏం రాసుకోవచ్చు మనము I is equals to your, this one is how much for me? I is equals to your I naught into your sin of your omega t plus of your phi part of relation, and current will be I is equals to V naught. In the previous condition lo voltage leads the current కాబట్టి current will be lagging by your phi part of relation. So points కొంచెం ప్రాక్టీస్ చేయాలా, and you can easily do it by 2-3 times of your revision, or if you give it 2-3 times of your study for this one, you can easily do such type of questions better. And at resonant frequency is equals to your 1 by 2 pi part. So FR is known as resonant frequency given condition. So in resonance series, Z is equals to R and current is equals to your max. Okay na? ఈ మెటీరియల్ లో కూడా కొన్ని కండిషన్స్ ఉన్నాయి నాన్న. కండిషన్స్ ఒకసారి చదవండి క్లియర్ గా, దట్ విల్ హెల్ప్ యూ అవుట్. ఇది న్యూమరికల్స్ లో చాలా యూజ్ అవుతుంది బేసికల్ గా. సో వెన్ యూ స్టార్ట్ డూయింగ్ ద న్యూమరికల్స్, like say if I am giving you sometimes omega is lesser than of your resonant frequency, appudu XC will be greater than of your XL. Inductive capacitance will be greater than of your XL. That is before resonance current leads. I can say right now that is before resonance current leads Okay, the same way, one more point for me here right now. If omega is equals to omega r, okay, so that is XL will be greater than of your XC. That means after resonance, that means omega greater this. Sorry, this one I'll write as of your greater. If omega is equals to omega r, that means XL will be greater than of your XC. That means after resonance, voltage leads. After resonance, voltage leads. So in series resonance circuit is called as a what beta? Acceptor circuit. So I can make one point here right now. The series resonant circuit is called acceptor circuit. Is called acceptor circuit. Is called what? Acceptor circuit. Okay. So we got all the circuits combinations beta at a time. So you can just check it out once. ఒకసారి బాగా go through చేయండి. That will help you out for you the beta basic conditions. Okay. ఇంకా చాలా ఉన్నాయి derivations, choke coil, power in your AC circuits ఉన్నాయి. And you need to do the problems. A lot number of your problems you need to practice in this one. Then only you can try to do it out. We are also having the parallel AC circuit for advanced. Mains కి మాత్రం నాకు తెలుసు అది లేదు. అడ్వాన్స్ మాత్రం అది ఉంది. అండ్ ఇంకోటి ఉంది మనకు ట్రాన్స్ఫార్మర్స్ అండ్ ఎఫిషియన్సీ ఆఫ్ యువర్ ట్రాన్స్ఫార్మర్స్ పార్ట్ ఆఫ్ రిలేషన్. So that will try to do it in the tomorrow session of your class. So ikkada varaku aithe emana doubts unte please let me know. I'll try to help you out for you right now. ఒక 2 ప్రాబ్లమ్స్ చేపించేసుకుంటాను చూడండి, దాని తర్వాత you can practice it out some. See this question beta. In LR circuit, a sinusoidal voltage in LR series circuit అనుకుందాం. Sinusoidal voltage V is equals to V naught into sine omega into t is applied. Okay, it is given that L is equals to 35 millihenry, comma, capital R is equals to 11 ohms, and VRMS is equals to 220 volt, and omega by 2 pi is equals to 50 hertz ante frequency, and pi value take it as 22/7. Find the current amplitude. Find the current amplitude. Current amplitude ante enna? Peak current. What type of a circuit it is? Can anyone tell me? LR circuit, series combination of your LR circuit. Ante we need to write a resistor and we need to write your RL circuit. Okay, this one is connected to your alternating source here. Okay, so this one is V is equals to V naught. This is given in the problem as 220 volt, comma 50 hertz. Okay, and this L is equals to 35 millihenry and capital R is equals to 11 ohms. So calculate the value of XL. So what is the value of your XL? So from this one there is a flow of a current. So first resistance of inductor is XL is equals to omega into L. Omega is equals to 2 pi into your N into your L. So it is your 2 pi, N value is nothing but 50 hertz into L value is 35 millihenry, that is 10 to the power of -3. So that will become for me, how much you are getting, you see right now this one. ఇదంతా వస్తుంది చూడండి.
3.5.
So this one is a 3.5 into pi. Pi value given 22/7. So ఇదంతా వస్తుంది చూడు approximate గా. 5 into 22 divided by 7.
So 11.
11 వస్తుందా? 11 ohms. R కూడా ఎంత ఇచ్చాడు మనకు? 11 ohms. So impedance ఎంత అవుతుంది? Z is equals to under root of this one is R square plus of your XL square. That is under root of this one is 11 whole square plus this one is also 11 whole square. But this one will become for me 11 into root 2 ohms. So I can calculate the current from this one. This will be measuring IRMS current. So IRMS is equals to your VRMS divided by Z. So VRMS is given how much for me? 220 divided by Z is 11 into root 2. So we are getting IRMS is equals to idantha ostundana 11 ones are 11 twos are. So this will be your 20 divided by root 2 amperes. And this can be written as root 2. I can write as 2 into 2. So that will become for me enta
10 root 2.
So this one will be 10 root 2 amperes. This will be your 10 root 2 amperes. So IRMS I got as of your 10 root 2. Now what is asking peak current? We know already peak current formula. IRMS is equals to your I naught by your root 2. So peak current will be IRMS is equals to root 2 into your IRMS. I naught is equals to root 2 into IRMS. So it is root 2 into this one is 10 into your root 2. Root 2 into root 2 is how much for me? 2. So this will become for me 10 into 2, that is 20 amperes. So peak current in this one is your 20 amperes. Can anyone tell me what is the phase difference beta? అడగలేదు, ఒకవేళ అడిగితే phase difference will be equal to your how much? Phase difference for this one will be equal to how much? గుర్తుంది కదా diagram? So this one is inductor. Inductor అంటే ఎక్కడ వస్తుంది? This one is your VL and another one is nothing but of your VR. This one is your resultant V. This is angle of your phi. So phase difference ante tan phi kada. Tan phi is equals to VL by your VR. VL ఎంత వచ్చిందన్న? VL is equals to your I into your XL divided by I into your R. I gets cancelled. So tan phi is equals to XL. XL how much we got? 11. R is also 11. So this will be equal to 1. So phase angle will be equal to how much for me? 45 degrees. Or else in terms of radians, if I am writing pi by 4 radians. Clear? Is it clear for everyone? Is it clear for everyone? Okay. So we'll try to do more number of numericals in tomorrow's session of a class. Today you try to open your material in NCERT also, sir, open cheyandi and try to read from the material and as well as of NCERT. ఒకవేళ టైం దొరికితే ఐపీ మీటర్ కూడా తీసి ఒకసారి ఆల్టర్నేటింగ్ సర్క్యూట్ గో త్రూ చేయండి. ఆల్మోస్ట్ ఆల్ అంతా అయిపోయింది. ఒక పవర్ సర్క్యూట్ డెరివేషన్ ఉంది, అది టుమారో చేపిస్తాను. అండ్ ఇంకోటేమో ట్రాన్స్ఫార్మర్. మనం యాజ్ పర్ షెడ్యూల్ ఉన్నామా లేకపోతే వెనక ముందులో ఉన్నామా? షెడ్యూల్ చూడలేదు. ఓకే, నోట్స్ దీంట్లోనే ఉంది. సో యూ ట్రై టు గో త్రూ ఇట్. కంటిన్యూషన్ నోట్స్ పంపిస్తున్నాను. 302, 301, 303, 304, 305. ఓకేనా? Then 306, 307. వచ్చింది అందరికి నోట్స్? దీంట్లోనే ఉంది ఈరోజు చెప్పిన నోట్స్ మొత్తం. ఇట్ ఈస్ సమ్వేర్ ఫ్రమ్ పేజ్ నెంబర్ ఇక్కడ గ్రాఫ్ ప్రాబ్లమ్ చేయండి అన్న. Somewhere today's notes, this one. Okay. Chalo. If I am having any doubts, please let me know beta. Metal మాత్రం ఖచ్చితంగా చేయండి. అట్లీస్ట్ లెవెల్ 1 లెవెల్ 2 క్వశ్చన్స్ చేయండి. దీంట్లో పెద్దగా క్వశ్చన్స్ ఏమీ రావు గట్టివి. సో అట్లీస్ట్ బేసిక్ ఫార్ములాస్ గుర్తుండాలా. రేపు క్వాలిటీ ఫ్యాక్టర్, చాకో ఆయిల్, పవర్ కాన్సెప్ట్స్ చేసేసుకొని దెన్ ట్రాన్స్ఫార్మర్స్ చేస్తాం. దట్ విల్ బి ద ఫుల్ స్టాప్ ఫర్ దిస్ టాపిక్. ఓకేనా? అండ్ ప్లీజ్ ట్రై టు రివైజ్ ఇట్ కేర్ఫుల్లీ అండ్ ట్రై టు రీడ్ ఇట్ ఫ్రమ్ ది ఎన్సీఆర్టీ ఆల్సో అండ్ ఐపీ మెటల్ కూడా ఒకసారి చదవండి. ఓకే, చలో బేటా, టేక్ కేర్, బాయ్. కౌశిక్
బాబు, జేఈ మెయిన్స్ అప్లికేషన్ ఎవరైనా అప్లై చేసి ఉంటే నాకు కానీ శ్రీధరెడ్డి సార్ కానీ త్వరగా సెండ్ చేయండి. మీరు అప్లై చేసిన పీడిఎఫ్ అప్లికేషన్ ప్లస్ మీ అప్లికేషన్ నెంబర్, మీ నేము, ఐడి నెంబర్, మీరు జేఈ మెయిన్స్ కి క్రియేట్ చేసుకున్న పాస్వర్డ్ అండ్ డేట్